With the section 3.1 and to be able to nail down this whole solving by graphing thing. So when we look at this, our first step then would be to solve them for which variable?
Y.
Solve for y. So we're going to start with x minus 2y equals 4. And as we begin to solve for y, we need to take away the x, both sides. So negative 2y equals negative x plus 4. And even if we did this yesterday, repeat won't hurt anybody. And then we divide both sides by negative 2. Good. So when we divide by negative 2, just be careful that you have this broken down into two problems because the whole thing is divided by negative 2. So this one, negative x divided by negative 2 is 1/2 x. And that's a very common mistake that somebody said, that it's thinking 2x, because you see a 2 and you see an x, but when it's divided by, there's a hidden 1 here. So 1/2. And then 4 over negative 2, though, that's where our 2 is. So we have that. So we'll go ahead and we'll graph that one. So we'll make a graph over here. We have to have our x-axis and our y-axis. And I'll go ahead and label them x and y. And so we're going to go ahead and graph 1/2 x minus 2. So where do we start that graph? Negative 2 on which axis? The y-axis. So negative 2. And then that takes us, what's the 1/2 do? Up 1 and right 2. So up 1, right 2. Going on and on and on. And then we have to make our very, very best straight line that goes through these. Like that. Okay. And this one isn't going to be as forgiving on the graph as the other, but I can write better with it. All right, so let's take a look at this one. 3x plus y equals 5. So we need to get that one solved for y. Y equals negative 3x plus 5. That's great. And so we start that one at positive 5. 1, 2, 3, 4, 5. And then negative 3 as a slope tells you to do what? Down 3. Good. Down 3 and right 1. Even though the 1 isn't there, the 1 is understood. So down 3. 1, 2, 3, right 1. Then down 3, 1, 2, 3, right 1. And it's nice that that's showing up right on the line where it belongs. And so our solution is the point of intersection, which in this case is what? 2, negative 1. Great. So this is our case where we solve it, we get a point of intersection, and so our solution is 2, negative 1. It should work in both of the equations. And if you wanted to go ahead and check, you would plug it back in just to make sure. Just a verbal check real quick. 2 minus 2 times negative 1 would be 2 plus 2, which is 4, and that works. 3 times 2 is 6, plus negative 1 is 5, so that one also works. And then we do have one more on that sheet, but then I'll pause for a minute, and then I'll give you the other sheet as we move on so we can do the second half of this. And we're going to look at this problem about ice cream cones. And so figuring out how much you can get with a certain amount of money. So ice cream cones cost $2 for a small and $3 for a large. Everyone on the team gets, the team of 14 gets a cone. If they spend $39, how many got small and how many got large? So we need a couple of variables. We'll pick S and L or X and Y, or somehow we can do that. So you said S and L, so we'll do that because that was the first thing I heard. S stands for what? Small, the number of small cones, and I want to be specific about that. The number of small cones. And making sure to label things is good so that you know that when you finish you have the right what your solution is telling you. And L for large, I'm going to use like a cursive L just because the lowercase looks too much like a 1. Number of large cones. Okay, so there's two things happening here. We have to take into account the $2 for a small, the $3 in a large. We have to take into account that there's a team of 14, and we have to take into account also that there's $39 total spent. So can somebody give me an equation that would deal with the S and the L? 2S plus 3L does equal something, but it doesn't equal 39, because $2 times the number of small plus $3 times the number of large, this is our money equation. So that equals, so this is an amount of money, this is an amount of money, and this is an amount of money. But the 14 is important. Can somebody figure out what equation we would use with the number of small cones and the number of large cones and the 14? I'm sorry? Point slope would be a little difficult to use here, but I'm looking for an actual equation that uses S and uses L and the idea that we have 14 total cones. Okay, I've heard a couple of things. S plus 3L again would bring the money in, because the 14 doesn't have anything to do with the money. 14 tells you how many team members, but also how many whats. It'll end up in standard form, but that might not help us. Okay, for just real quick, we have 14 players. Each one of them gets a cone, so that means we have 14 cones. Here's the number of the small cones and the number of large cones. And we have 14 cones. So I think you guys are overthinking it. We have this many small ones and this many large ones. So altogether we have how many? 14 altogether. So that implies that what equals 14? 14 altogether means we're doing what with these numbers? Adding them. So S plus L, the number of smalls plus the number of larges, equals 14. Now they are equations in two variables. You can do a couple of different things to be able to figure this out. We could solve by graphing. We could solve by chart. You could do a whole bunch of things. You could guess and check at this point. We have S's and L's, which makes it harder to think about with X's and Y's. We could substitute in. We haven't really done that method yet, but we could do several different things with this problem in order to solve it. So what are you thinking? What would you like to do with this? You want to try and graph it? Okay, so we can do that. I don't have a graph paper brought up, but we can do that. Let's see. So instead of doing the S's and the L's, let's do the X's and the Y's. x's and y's, because it's sometimes easier to think in terms of x's and y's, especially with graphing. So 2x plus 3y equals 39. This one, some of you wanted to put them in different forms. So this one turns into y equals what? Negative x plus 14. This one, 2x plus 3y equals 39. So let's get this one. So minus 2x. 3y equals negative 2x plus 39. So divide by 3 and you get plus 13. And as much as the graphing sounds interesting, we've got 13, we've got 14 on there. That might be a little bit annoying. Let's look at our calculator method. Okay, with that chart. And let's see if we can figure it out with that. We've got them solved for y, which is our first step for this. There's our y's. We're going to set it equal, y equal, and we're going to do negative x plus 14. And we're going to do negative 2/3. If you're using a fraction, please put it in parentheses just to make it stand apart so that there's no kind of strange errors that come out. Plus 13. If you have a TI-84, it kind of automatically comes out as a fraction, so it's not as critical, but with the 83 plus, that makes it better. We're going to look at our table. We don't even need to look at the graph. Let's look at the table. All right. And we're looking for where? We're looking for where the y values are the same, right? Okay. Back to here, y equals. Okay. Back to y equals. We put those in, and to find the table, you do the second of graph, and we look at the table, and we're going down until we find where the y values are equal to each other. So that's at when we have 3 in the x and 11 in the y. So here's 3 in the x and 11 in the y. So that tells me we have 3 small cones and you have 11 large cones. So this one, actually, the table did work out well. You could have taken the time to graph it out. Honestly, when we get a little further down the road, we're going to have a method where we can either substitute in or use a process called elimination to solve. But for right now, since we're talking about graphs and tables, we're pretty much at the point where we have to do it this way. So that's just where we are, and we're going to do that. You can't find where they match? Okay, hold on a second. I'll come to you. So now that we've looked at graphing and looked at a little bit more as far as how these things go, we can talk about the possibilities. The ones we've done so far, they've had a solution. So one possibility is that the two lines would intersect each other. We have some words that need to go with that, because you may have encountered in Algebra 1 where you've got to find the solution. We have a name for that. We call that situation that it's consistent. Consistent means it has a solution, and it's independent, meaning that the two lines are completely different lines from one another. The other things that might happen is that the lines might be parallel. So if the lines are parallel, that means that how many solutions would there be? Well, if they're parallel, do they ever cross each other? No. So there's no solution on those. Okay? Parallel means no solution, and we call that inconsistent. So they are still technically independent of one another, but our main word we're looking for is inconsistent. There is no solution. So parallel, intersecting, and then coincident. That one looks a little bit odd, but a coincident is when you solve the one for y equals mx plus b, and you graph it. And then you solve the other one for y equals mx plus b, and you graph that one, and you found out that it was actually just the exact same line. They may have tried to fool you at the beginning and found out, but when you solved it, you found out that it was the exact same line. So coincident lines are actually two of the exact same line that are right on top of each other. I didn't even draw it twice because there's no point, because when you try to do the second one, it's right on top of it. So that means there's infinite solutions. It's still consistent, meaning that it has at least one, but instead of independent, it's dependent, because both of them are exactly the same, so that would make them dependent upon one another. So one solution, no solution, infinite solutions, but we need to add into your vocabulary independent, inconsistent, and dependent. And so we're going to go through and we're going to figure out whether or not these things are independent, inconsistent, or dependent based on what the slope-intercept form comes out to be, what the mx plus b comes out. So when something is independent, that means they're going to intersect, and that means that their slopes are not equal. It doesn't matter if they're perpendicular. It just means that their slopes are not equal. Different slopes will tell you that it's independent. In other words, that there's one solution. If you have the same slope, but the y-intercepts are different, then it's inconsistent, meaning no solution. But if you have the same slope and the same y-intercept, it's really just the same line. It's coincident, but that means that it's consistent and it's dependent. Okay, so dependent, inconsistent, and independent are the three words that we're going to be trying to apply to these. Now you've got that on your paper, but just for the sake of me being able to point, this one is independent with one solution, different slope. This one is inconsistent. And I'm putting them up on the boards, and we're going to do 1, 2, 3 with your fingers so that you can tell me what you believe these to be. And then finally, dependent. All right, so just one line. All right. So we have these equations that are right here in front of you. And in order to determine if they're dependent or independent, we're going to solve them for y. Okay, because we need to have them in mx plus b form to figure out if they're independent, inconsistent, or dependent. So let's do these. Let's bring this over here. We'll do these right here. So 3 plus 2y equals 14. Let's solve that one for y. 3x. So we have, take away your 3x. You're doing it here. I'm just going to do this up here while you're doing that. And after you have that one solved for y, we need to solve the other one for y so we can see what's happening. All right, so we have this. So what I want you to do is I want you first of all check and make sure that you've got your equation solved for y. That's our first step. And so thinking about our three choices and the criteria, independent, inconsistent, or dependent, I want you to give me a 1, 2, 3. Show me which one this one would be. Would it be independent, inconsistent, or dependent? Okay. So you don't have to imagine the scenario. What did we say? We said we're looking at the slopes, right? And what did we say the slope situation? Read from your paper. For independent, the slopes are different. For inconsistent, same slope, different y-intercept. And for dependent, we have same slope, same y-intercept. So, okay, that clarified it for a few people that are now putting in their opinions. And yes, so it is independent. Because what's the slope in the first one? Negative 3/2. And then the slope for this one is 5/3. So we don't care what the y-intercept is, as if the slopes turn out to be different, it's automatically independent. So we have that one. So same process for the others. You have to go through, you have to find the y equals form, the slope-intercept form, and then you move on and do the others. So I'm going to go ahead and erase this one, and I do have it on the thing that we can look back on later, but we're going to get rid of this, and I'll give myself a little more room. We'll do the next one. You do the next one. Try and get ahead of me. All right, here we go. Making sure that we solve it for y. Okay, and you what ends up happening is you get a little bit faster. In Algebra 2, we are still showing steps, but some of the steps are more likely to be worked out in your head a little bit. And we do need to like double check and just make sure that my brain is working correctly. Okay. So just double check and make sure that our graphs our y equals match. Yeah, I want you to tell me, is it independent, inconsistent, or dependent? 1, 2, or 3. Okay. All right. So yes, good, 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 good. I think everybody got that right. So it's inconsistent. They're parallel. How many solutions would that mean? No solutions. Inconsistent. So no solution. And let's backtrack to this one. If it's independent, how many solutions? One solution. It's independent and it's intersecting. Independent, actually, this one is also independent. The parallel one is also independent, but it's inconsistent as well. This one's independent and also consistent. But if they were asking if these are our choices, we could say independent. This one's also consistent because there is a solution. Consistent means there's a solution. Inconsistent means there's no solution. Independent means that they are two separate lines. So technically this one also would be independent, but we're just going to stick with the inconsistent on that because that is really all we're being asked for with these questions. All right, let's solve this one for y equals. Solve this one, and we will wrap this thing up. Get rid of that. So y is 1/3. And then we've got the other one. We divide that by -6. 10/6. 10/6 reduces to 5/3. So then this one would be dependent. You can simplify it in decimals, but this one will come out with a 6 repeating, so you would have to make sure, yeah, you can do that. And if you're not having to use it later on, it's easier to do that, but if you're needing to use it later on and plug it into anything, you should leave it in fraction form. So dependent, so how many solutions? Infinite solutions. Notice I didn't say all real numbers are solutions, but infinite solutions. It's dependent. We were asked just in this question for inconsistent, dependent, or independent. We're doing that. We haven't graphed any one of them. And then finally our last one. I'm hearing from you that it's independent, but let's just really quickly do the work to make sure that we know why. So 3x minus 5y equals 8. Negative 5y equals negative 3x plus 8. Divide by -5. So y equals 3/5 x minus 8/5. And then the other one, 6x minus 2y equals 20. Negative 2y equals negative 6x plus 20. Y equals negative 3 or positive 3. 3x minus 10. Slopes are completely unrelated, so independent. They will definitely intersect when they have different slopes. So we have those, and that really does wrap up what we need to do for these, I believe. Yep, these are just done like that. So you'll spend the rest of the time working on your assignments that are due Monday. Everything's from this section. And soccer team, congratulations on your win yesterday. We're looking forward to hearing more good things. Hope you're having a great time. Bye.